You ever look up at a skyscraper, a massive bridge, and just wonder, how on earth do they build that without people getting hurt? I mean, it seems impossible, right? Well, the answer isn't luck. It's a plan, a really detailed, meticulously engineered blueprint for safety. And today, we're going to deconstruct one of those blueprints, a real corporate safety standard, to see the invisible systems that protect lives when you're working way, way up above the ground. So, here's our game plan. First, we're going to define the danger itself. Then we'll look at the blueprint designed to manage it. We'll break down the core strategy, which is called the hierarchy of control, check out the gear, cover the absolutely critical human element, and finally, bring it all home to see why this stuff really matters. Let's get into it. Okay, first things first. We have to really understand the problem we're trying to solve. When we say working at height, we're talking about any situation where gravity is, let's just say, not your friend. So the very first step in any safety plan is to define exactly when that risk becomes critical. So let me just ask you, at what point does a simple height difference need a huge, systematic safety response? You think it's what, 10 meters, 5 meters, maybe the height of a house? Well, I'm willing to bet the real answer is a lot lower than you think. There it is, 1.8 meters. That's about 6 feet. According to this standard, that's the trigger point. And it's not some random number they pulled out of a hat. No, it's based on tons of research into fall dynamics, and it's the point where a fall is very, very likely to cause serious injury or even be fatal. You fall from below this, you might get hurt. You fall from above this, you are officially in a high-risk zone that demands a formal plan. And, as you can see, the full definition actually goes even deeper. It's not just about the distance. Check out that second part. A fall from any height is considered working at height if you could land on, say, dangerous equipment, hazardous chemicals, or even into water. So here's the big takeaway. It's not just how far you fall, but what you might fall onto. All right, so we've defined the danger. Now let's flip the script and look at the solution. A safety standard isn't just some dusty binder full of rules sitting on a shelf. You got to think of it more like a master plan, a proactive system designed from the ground up to stop incidents before they can even think about happening. At its absolute core, that's what this whole thing is about. It creates a structured process. First, you identify every possible fall hazard you can think of. Then, you evaluate the risk for each one. And finally, you put specific controls in place to manage that risk. It's this continuous loop of vigilance. It just never stops. And this just shows you how incredibly comprehensive the plan is. It starts before a single screw is turned, right back in the design phase. It sets up a crystal clear priority for safety measures. It demands strict control over every piece of equipment. It puts in a non-negotiable permit system, and it makes sure every single person on that site has the right training. It really does cover every angle. Now we're getting to the absolute heart of this safety philosophy, the hierarchy of control. And listen, this isn't just a menu of options you can pick from. It's a strategic, ranked system. It's like a multi-layered defense against falls. And you always, always start with the most effective, most foolproof method you possibly can. Just look at this progression. You don't get to just jump to your favorite. You are required to start at the top. The best way to avoid falling from a height? Come on, do the work on the ground. If you can't do that, okay, can you build a solid platform with guardrails? No? Well, can you use something like a scissor lift? It's only after you've exhausted all those better options that you even start thinking about personal gear, like harnesses. The system literally forces you to pick the safest possible method every single time. And when we do get down to that personal gear, there's this really critical difference between fall restraint and fall arrest. A restraint system, that's like a short leash. It physically stops you from getting close enough to an edge to even be able to fall. An arrest system, on the other hand, is like a safety net. It only kicks in after you've already fallen, to catch you. So, because it prevents the fall from ever happening, a restraint system is always the preferred, higher priority option. So, we've got our strategy. Now let's talk about the tools of the trade. The best plan in the world is totally useless if you don't have the right equipment. But here's the thing. It's not just about having the gear. It's about making sure that gear is absolutely, positively flawless every single time it gets used. And just take a look at the level of detail we're talking about here. Every single piece of equipment, from a permanent walkway to a simple ladder to a safety harness, is governed by its own specific, detailed engineering standard for both how it's designed and how it's inspected. This makes sure everything meets these tough, non-negotiable safety requirements. This isn't guesswork. This is pure engineering. And that gear? Oh, It lives a very controlled life. Before it's even used for the first time, it's formally commissioned to verify it's safe. Then it's subjected to constant inspections before every single use and on a routine schedule. And if any fault is found, or if it's ever actually used to stop a fall, it is immediately pulled from service. No questions asked. Safety is just this continuous process of verification. Okay, we've covered the strategy and we've covered the equipment, but there's one more piece to this puzzle, and you could argue it's the most important one of all: the people. The best plan and the best gear in the world are completely meaningless without trained operators and strict, unbreakable procedures to guide what they do. I just want you to let that sentence sink in for a second. This is not a suggestion. It is an absolute ironclad rule. Before anyone does a high-risk job at height, there has to be a formal, written permit. Think of it as the final checkpoint, the formal sign-off that says, yep, we've reviewed the plan, we have the right gear, and we are ready to do this safely. So what kind of work demands this level of scrutiny? Well, it's pretty much all the high-level controls we've been talking about. Using a scissor lift, rappelling down a structure, or clipping into a restraint or an arrest system, every one of these activities requires that formal permit to work. It connects the procedure directly to the risk. And underneath all of this is a simple truth. Training is not a one-and-done event. The standard requires that every single person has to prove they're competent for the task they're doing. And this gets reinforced with ongoing hazard awareness training to make sure that safety is always, always top of mind. All right, let's bring this all together and talk about the big picture. We've pulled apart this complex system of definitions, hierarchies, equipment checks, and permits. So what's the point? What's the ultimate goal of all this? And that right there is really the key takeaway. When you see some massive construction project get finished safely, it's not because they got lucky. It's because of a plan just like the one we've just been exploring. Robust safety is the result of a deliberate, systematic, and incredibly comprehensive design, where every little detail is considered and every risk is managed. It is anything but an accident. So I'll leave you with this thought. We've just taken a little peek behind the curtain at one safety system. But these kinds of blueprints, they're all around us, keeping us safe in ways we probably never even notice. From the food you eat to the car you drive, our whole world is built on these invisible systems of safety. What others can you think of?